Hi again, welcome back. In this video we begin our discussion on sequences and series. A number of aspects of sequences and series are addressed in this and in the following videos on the site. The overall topic has a very practical orientation and leads in part to some important aspects of financial mathematics. So we have two terms to clarify at the outset. First, a sequence is a collection of numbers connected by commas. There can be a finite or infinite number of values in a sequence. A series, in contrast, is a sequence of numbers which are connected by addition. Hence, 1, 5, 18, 42 is a sequence. In contrast, 1 plus 5 plus 18 plus 42 is a series. Note that the numbers in the sequence are pretty random, which in practice is not very helpful. It is far more useful if there is a rule connecting the numbers together, just like in a family. Some sequences or series help us to solve mathematical equations. Very powerful. Some sequences or series help us to model financial investments. Series with the plus sign are used frequently in statistics, as well as in physics and in computer science. Some series are the basis of much of our calculus, for example, when we add up all the tiny parts to obtain the area under a curve. Despite the fact that you add up an infinite number of terms, many series total up to just an ordinary finite number. Just as we can have lots of rules in terms of our mathematics, we can also have lots of meaningful sequences. In other words, there's rules between them. Two common sequences, which we will return to shortly, are 4, 9, 14, 19, 24 as an example of one of these. And notice that the rule here is that there is a common difference of 5 between successive terms. We call such a sequence or a series with a common difference between successive terms as being arithmetic. But if we have the sequence 2, 4, 8, 16, 32, then our rule here is that there is a common ratio of 2 between successive terms. 2 times 2 is 4, and so 2 times 16 is 32, and so forth. We call a sequence or a series with a common ratio between successive terms as being a geometric sequence or series. So we are going to concentrate on our arithmetic and geometric sequences and series in this course, but there are lots of other series which are much more complex, and we are not going to return to those this year. For example, a Fourier series is useful when we want to study something which repeats its pattern over time. For example, sound waves or waves in the ocean. We also have other kinds of series like Taylor series and Maclaurin series for finding the values of a function at a particular point. Now don't worry about these, they will give you enjoyment in your university studies. Absolute untold enjoyment. There are more than 50 types of series in just the general series categories, and we're going to have a look at 2 of those. Having looked far into the future, we can now retreat to the 2 simpler sequences and series we need to address on this site. In summary, a sequence is a collection of numbers or terms separated by commas. A series is a sequence of numbers or terms separated by plus or minus signs. In other words, for a series, we can add up a number of terms together. An arithmetic sequence or series is where terms have a constant difference between one term and the term before it. In contrast, a geometric sequence or series is where terms have a constant ratio between a term and the one before it. So you should now have the steps to differentiate between sequences and series, and at least know the differences between arithmetic and geometric sequences and series. Hope I've helped you to clarify the concepts. Thanks for watching this video. In the next video in the series, we look at how to discuss the general term in an arithmetic sequence or series. Hit the like button and subscribe if you haven't already. Also go and do some questions in Test Yourself 1 on my website, drjsmaths.com. Just click the back button on your screen now. Add a comment or send me an email if you have any questions. Good luck. See you later.